Hello friends, welcome to my channel Rebel Coaching Center. So today I'm going to explain you that is the 12th standard maths first chapter, relation and function. So relation, what is relation? So if a term A and another term B are two non-empty set, if they both are not in empty sets, then a relation or from A to B is a subset of A into B. It will be a relation will be subset of A into B. And next, domain and range. As you know, domain is the first number and range is the next number. So next, in relation there are types of relation, different types of relation. The first type is void relation. So in this, as null set, so A into A. So for any set, in any set, if you say in any set A, let us take A, so null set is a relation of A. It is a relation on A. Then it is called empty or void set. Empty or void set. And the next relationship is universal relation. So A into A is equal or subset of A into A. So A into A, it becomes A into A, we can say it as it is a relation on A. In an A it is a relation. A into A is a relation. It is called universal relation. So in this, A into A is a relation on A that is a relation, then it is called universal relation. And next is identity relation. The relation is equal to A comma A belongs to A. If it is this relation, then it is called identity relation of A. So after identification relation, next is the reflexive relation. So a relation, or it is a reflex relation, if every element of A is related itself, they are related itself. Next, symmetric relation. A relation or is said to be symmetric relation if A comma B is belongs to B comma A and it belongs to R A, and A comma B belongs to A. This you have to remember. Next, antisymmetric relation. In this relation, if A comma B, if it belongs to R, and B comma A, if that belongs to R, then A is equal to B comma B, and A comma B if it belongs to A. These are the relation. And last, the relation R. So next is transitive relation. So in this transitive relation, a relation or it is said to be transitive relation in if it is said to be transitive relation if A belongs to R, A comma B and B comma C belongs to R, then it is called as transitive. Next is equivalence relation. A relation is said to be equivalence relation if it is simultaneous, reflexive, symmetric and transitive. So if it is transitive, symmetric, reflex, if it has these three components, then it is effective equivalence relation. Next, partial. In this partial relation, the relation should be equally transitive. In this, it will be reflex reaction, symmetric reaction and antisymmetric reaction if will be there. And next is total order reaction. In this, all total partial order, all the total reaction will become the total order relation. Total order relation. So next is composition of relation. See, if a relation SOR is called the composition of R and S, then the first thing should be R OS should not equal to SOR. The next thing is SOR minus 1, R minus 1 and OS minus 1 is known as reversible rule. This is known as the reversible rule. Next, important results of relations, they are the most important results of the relation is if R and S are two equilibrial relations on a set A, then R is intersection of S is also known as equivalence relation on A. So if R and S are two equivalence relation on a set A, then R will be belongs to S is also an equivalence relation of A. And if the union of two equivalence relations on a set is not necessary to be equivalence relation on the set, it should be not be equivalent necessary that it should be set. And next, R is an equivalence relation on set A, then R minus 1 is also equivalent relation on set A. So if R is relation on set A, then R minus 1 is also relation on set A only, it will be. And like that only, if set A has n element, the number of reflex relation from A to A is 2n2 minus 1. And if A and B have two non-empty finite sets consisting of m and n element respectively, it has two non-elements, and then A into B consists of m n ordered pairs. So totally the relations of A to B is 2m into n. Next, another operation in that closure property. Closure property, an operation on an non-empty set is said to satisfy the closure property. It is said to be satisfy the closure property if it has A belongs to S, B belongs to S, then we can say it as closure properties, and it has some properties and some rules. So types of binary operations, there are types of binary operations. Associative law. So if a binary operation on a non-empty set is said to be, it is said to be associative if A comma B is equal to A and B into C. If it is in this, let R be the set of real numbers, and then addition and multiplication on R satisfy the associative rule. Next, communication law. Communication law. A binary operation. So in communication law, it will be A into B is equal to A into A. See, like this, if it is 2 minus 3, but 2 minus 3 will not be equal to 3 minus 2, okay. Next, distributive law. So in this, A, B into C, in that A, B, so in distributive law, if A into BOC, it is A into BO, A into C, it will be like this, and right hand side distribution is BOC, in that B into A and C into A, it will be like that. It will be like that. So this was your chapter, the relation and function. So they will ask on this basis only, they will ask the sums, the types of relation they may ask, and also the rules, closure properties, and the binary operation and their laws. On this basis they may ask you the sums in your final exam. So okay friends, study it well, understand this. If you want, I will submit, then I will give the notes. So okay friends, like the video, comment on the video, and subscribe my channel and go to the for more videos. will see you in my next video explain another chapter. Till then, take care. Have a nice day. Bye, my dear friends.